today, on your paper, it says describe what you see is happening on the velocity versus time graph. So take a look at your graph, and I want you to describe on your barrier sheet what you see. I want to give y'all about 5 minutes to complete. All right, we got about 2 minutes. All right, do anybody need more time? All right, so our bear work today said describe what you see is happening on the velocity versus time graph. What do we see happening at point A?
Accelerate.
It's accelerating. Do I have a positive acceleration or a negative acceleration? Positive acceleration. All right, when we get to point B, what do we see? It's at a constant speed. So what is my acceleration when it's at a constant speed? 0. Yes, it have a zero acceleration. Point C, what's going on? Decelerate. So it's positive or negative? Negative. Alright, and point D, what's going on? We accelerate. So we're going back to what? Positive acceleration. Alright. Now we're going to move into concept 3. Concept 3, we're going to be talking about Newton's laws. Give me 1 second. Let me get my board up. Alright, our I can statement for today. Somebody look at the board to your right and tell me what your clear learning target is for today. I can't hear you. What is it?
I can define force and Newton's first law.
Alright, so today we're going to be defining force and Newton's first law. I didn't make up these laws, just to let you know, okay? I did it. Alright, so force. Force is the push or pull one object. It's the push or pull one object exerts on another. It's the push or pull one object exerts on another. Force is being measured in newtons. So 1 Newton equals 1 kilogram times meters per second squared. Force is measured in what? What is the force measured in?
1 Newton.
1 newtons. Yes. What's wrong back? You need those? Alright, so force is the push or pull that is exerted on an object. And force is being measured in newtons. Force can cause a change in direction of an object's motion. And the more than one force can act on an object at one time. So the force can change the motion of the object, and force can also the object can have more than one force that can act on an object at one time. So when you have more than one force acting on an object, then you have what is called the net force. Somebody read to me where they see it says net force. Yes. The combining of forces when 2 or more forces act on an object. So 2 or more forces act on an object is called your net force. So here we have a stack of books on the board. We got a force coming from the left of 2 newtons, and we have a force coming from the right of 5 newtons. What do we think is going to happen to those books? Are they going to shift to the left, or are they going to shift to the right? To the left. Why do we think it's going to shift to the left?
Because the right means has
Yes, so there's more force coming from
the right.
the right than it is from the left. Now, to figure out how much difference that force is, you will subtract 5 from 2, and then you will get 3 newtons to the left, will be your net force. So the net force on these books is 3 newtons to the left, because you subtracted 5 from 2, and you got 3. Alright, so what is force? Alright, and what is the net force?
It's combining the forces when 2 or more forces act on an object.
Yes, so the force is the push or pull on the object, and then the net force is when you have 2 or more forces act on an object. Okay? Are we good to go to the next slide? Alright. Alright, so force on an object can be balanced or unbalanced. A balanced force is the forces that are equal in size and opposite direction. Balanced force is the force that is equal in size, and it comes from two opposite directions. So this particular force does not change in motion because the net force of the object is going to be 0. Alright, so an example of balance force. I have 4 newtons coming from each side of the books. What's going to happen? It'll stay where it's at because it got the same force that acted on the object. So my net force will be 0. So the balance force is equal size when it comes from opposite direction. Now we have our unbalanced force. Unbalanced force are forces that are not equal in size and opposite in direction. So the net force causes the object to move in direction of the force. So for example, from the left, I have a force of 2 newtons, and then I have an additional force of 7 newtons, and then from the right, I got a force of 3 newtons. What do you think my net force is going to be? How you see?
2 plus 7 minus 3.
Okay. He said 2 plus 7 minus the 3. Correct. Your net force in this case is going to be 6 newtons to the right. Do we understand why is it to the right? Why?
Because there's more on the left side.
Yes, you got more force coming from your left side than your right. Do we understand how to calculate the net force? Yes? Okay. Alright. Y'all ready to go to the next one? Y'all sure? Okay. Alright, so Newton's first law of motion. So Sir Isaac Newton came up with 3 laws in the year 1687 that describes how forces affect an object's motion. Newton's first law. Somebody read me what the first law is.
An object will move at a constant velocity until a net force acts on it.
Yes. So Newton's first law is when an object moves at a constant velocity until a net force acts on it. So that means when 2 different forces coming towards that object, causing it to move. An object in motion will stay in motion unless a force acts on it. And an object at rest will stay at rest unless a force acts on it. So if I start rolling the ball there will not be a net force on it unless I give it some another force coming from it from a different direction. So if you was playing soccer and you kick the ball down the field and then another player comes from the left and from the right and they hit the ball, the force it will become a Newton's first law because you had a force coming from opposite ends or either side that hit the ball. Does that make sense? Yes, so they'll collide together. Alright, so Newton's first law is also known as the law of inertia. Inertia is the tendency of an object to resist a change in motion. The more mass an object has, the more inertia it has. So we're looking at this image on the board. And what we're going to pretend like is this person is pushing on their brakes. What do you think is happening in the first picture to the left? What happened? Their body what? It went forward. And then when they push their brakes with their seatbelt on, what happened? It stayed still. That's an example of inertia. So their body, without the seatbelt on, they didn't have any kind of resistance that kept them from changing motion. The seatbelt in the picture to the right made them resist from moving. So when you slam on your brakes, your body still flies forward because it wants to stay in motion like it was before it braked. This is why you wear a seatbelt. Some of y'all probably still don't wear no seatbelt, please.
When I'm driving.
All right, so somebody tell me what's our clear learning target for today? All right, so what is the definition of force?
Push or pull on.
Of an object. Yes, the push or pull of an object. Then what is Newton's first law?
The cosine and force.
An object will move at a constant velocity to a net force action.
Yes. Yes. So when an object is at a constant velocity and it does not move unless a net force acts on it, it's your Newton's first law. All right, everybody go to page 24 in your packet. On page 24 is a practice set that you are going to go through 1 through 10, and you are going to basically answer the questions based off of your understanding about force and Newton's first law. Okay? If you get stuck, you can ask me any questions you may have, but you also can go back to your notes that can kind of give you a little bit more detail on how you can answer that particular question. Now, for number 1, it tells you to draw and label a picture to show the difference between balanced and unbalanced force. If we go back to our notes, what is the balanced force? Two of the same what? Two of the same forces from each opposite side, right? And then unbalanced force is what? Yes, different forces from each side. So you can draw a car. You can draw a ball, something hitting the car from both sides. Just draw me some type of image on number 1 that showcases the difference between how do you determine between balanced and unbalanced forces. You can draw a person kicking a ball and the person from the left kick it harder from the person on the right. That can be your unbalanced force. Or you can draw me the same picture with them, the same two people kicking the same force toward the ball. Does that make sense? It can be stick people. It does not have to be a perfect image. Okay, so don't overthink the picture. Or like our example in the presentation, it gave you a picture of some books and a force coming from the left and a force coming from the right. You can use that same image, but I need to make sure that you understand the difference between balanced and unbalanced force.
Ms. Newton,
Yes,
are
ma'am.
we supposed to put, like, you said used, like we can use like the books. Are we supposed to put the numbers too?
Yes, so I can know how much, what force.
Like any number?
It can be any number. Make sure you are indicating how much force is coming from the opposite direction. It does not matter what the number is, as long as when you do your balance, they're the same number. If you do your unbalance, you have two different numbers. What's up? Yeah. Yes.
On number 3, what does it mean, the object at rest? Like,
It's not moving?
the thing ain't moving?
Yes.
I don't have enough room. What I did, I just do like this.
If you need a separate sheet of paper to draw your pictures, you may use another sheet of paper.
Okay, so show me how it's coming together, like where the force is coming from. We show 2 balls, right? So where the force coming from? I'm not gonna kick it, so I'm gonna push it. Like draw me an arrow showing me like this, something that's going to actually you can draw an arrow like how this is, and it's showing that the force coming from this way, this force coming from that way.
So kind of what I heard.
Yeah. Just indicate where the force is actually coming from. So you can draw an arrow going towards it. And put the numbers in there. So what you did is fine. Just put me some numbers right there showing me like how much force it is.
Kind of confused. Questions come from the doing the definition over, like, it's kind of different.
Okay, so you drew a picture right here, right? So you showing me how, so right now you're showing me unbalance. The difference between balance and you showing me unbalanced force right here. So it tells you to explain how balance and unbalanced force affect on the object's motion differently. So based off your definition. It gives the same force, right?
Yeah.
Okay, and then unbalanced force gives 2 different forces, right? So explain how the balanced force give off the same force, and then your unbalanced force get off two different forces, which will equals to you having to have a net force because you got force on the object. Yes, ma'am. Okay, so unbalance is right. When it comes to balance, it's the same force. Yeah, so both sides will be the same.
Make sure when you are explaining the difference between balance and unbalanced, your balanced force should have the same force coming from the left and from the right, or from the top and the bottom, wherever the force is coming from. And your unbalanced force will have two different measurements of force. So my left, I may have 10 newtons coming from the left, and I may have 5 newtons coming from the right. When you're working on your unbalanced force. Yes. What is the net force on the unbalanced force at the left? Yes. And we go with the notes.
I'm sorry, what is the force on the object that has a balanced force?
You got it? You sure?
So what is the net force on the object that has a balanced force? What real force? Force. What's up? Okay, so this your object, right? Okay, so this is your object, you got a force coming this way, and then you don't have a force coming from that way, right? Okay, so we can say this is your unbalance. Now this one, you need to draw me an area with somebody, draw another person here, and have them kicking the ball the same direction to this ball, and they have the same force, and they can be a balanced force. Ryan, think about a number. The number 4. It says, what is the net force on an object that has a balanced force acting on it? So what's your net force gonna be equal to, basically, what's asking you? On number 4, it's asking you what was your net force equal to on number 4. Remember, your net force is the difference between your two forces. The difference between your forces on the object. You did it?
force of what? 4. So if I hit 7 and 7, right here, what would be the force? Okay, so it's a net force of 8 newtons against force. Zero. So that means that your net force will be 0 or balance. So that should be 0. Does that make sense? It's unbalanced, right? So this unbalance means you feel like that your net force is, and your net force should have found the difference. So if I find the difference, I do what? Difference. You know, you good? You need some help? You need some help? Okay, here. Think about the weight. The weight is what? The weight is something. Yes, that's right. You need these? Yeah, I got it. Okay, so these are you get your net force. this one will be 10 plus 2 and then subtracting from 6.
Okay.
Alright, so, let's pause for a second. Make sure that when you are looking at numbers 5 and 6 on your paper, you are calculating the net force, and the net force is considered the difference between your forces. So you're gonna subtract them in order for you to get your answer. And make sure that your answer is in newtons, which means you have an N at the end of your number when you finish calculating your net force on numbers 5 and 6.